The second example here is a slightly more complicated fraction that we need to rationalise. You'll notice that for this one, we've actually got what's called a binomial. Okay, bi meaning two, nomial meaning number. It's got two parts to it, separated by a plus, as opposed to the first one that really just had one term, this 4 root 2. And when we're rationalising a fraction that has a binomial expression like this in it, we're going to need to deal with this in the same way that we dealt with these conjugates, or by using the result that we realised from conjugates. We saw before, and in fact this is the exact same expression as before, we saw before that if I multiply a binomial expression by its conjugate, so the one where the sign in between is the opposite, then I'm going to end up with a rational expression. And the logic is going to be pretty similar to the last one. What I want to be able to do is to just stick a square root of 3 minus 1 on the bottom here, because I know that that will end up with a rational expression. Problem is I can't just do that, but I can get one to be down there as long as I do something that is allowed in maths. And we said before that multiplying by 1 is allowed. I can always multiply by 1 and keep things unchanged. And of course, square root of 3 minus 1, which is the conjugate of the bottom here, divided by square root of 3 minus 1, is just a fancy way of writing 1. So I can multiply this by square root of 3 minus 1 on square root of 3 minus 1, and I'm really just multiplying by 1. And I'm multiplying along the top, multiplying along the bottom. When we're multiplying binomial expressions like this, we indicate that by putting brackets around them. So this is 5 root 3 outside of root 3 minus 1, all over root 3 plus 1, root 3 minus 1, expanding the top, 5 root 3 times square root of 3 is going to be 5 times 3. If you're not sure about that, see if you can do the intermediate steps to check it. Take away, 5 root 3 times 1 is just 5 root 3. On the bottom, we've already expanded this one back on the last page. I've done this multiplication and the answer was 2. You could do it in full again if you really wanted to, but I just want to get to the end of this problem. 5 times 3 is 15, minus 5 root 3, and I don't know what I've done there. This minus 1 shouldn't be there, because the end result of this is 2, of course. Sorry about that. So, to go through that again, this top part we expanded. 5 root 3 times root 3 was 5 times 3. 5 root 3 times minus 1 was negative 5 root 3. And the bottom we said expanded to give me 2. Okay. If you wanted to see exactly that being done, have a look at the first video that I did. We have already expanded that result. Got the answer as 2. I'm going to do a couple more examples on the next video, and then we'll finish up with rationalising the denominator.